come some answers at you. Number one, we have constant speed, or you could say constant velocity. In the reading, they said that for now, they're going to just use speed and velocity interchangeably. Someday we'll get into the difference between the two, but for now, they don't really care which word we use. But one choice would be to say constant speed or constant velocity. That's like you out on the highway, you set your cruise control. You just go in that speed endlessly. Second choice is to have changing velocity, or you could say changing speed, or you could say with acceleration, or you could say with deceleration. You could use any of those sort of phrases. That's you more like in the city doing your driving. You gotta hit the gas, then you hit the brake. Then you hit the gas, then you hit the brake. You rarely drive through town anywhere at a constant speed. You're constantly speeding up, slowing down, speeding up, slowing down. So that's our two options for moving. Choice one, constant speed. Choice two, changing speed, with alternatives possible. 3 is acceleration. 4 is average. 5 is instantaneous. 6, I'm going to go with V equals S over T, and I don't really care if you put the bar over the V that they insisted on in the reading. Like, I'm sort of indifferent toward that right now. If you did it, great. If you skipped it, who cares? But I'm good with V equals S over T. 7 is basically if you're speeding up. If your speed increases, if you move at a higher speed than before, something like that. 8, for future quiz purposes, I would actually prefer this equation that they didn't put in the box. For today, if you had this one, I'm fine with that. I think they drew a big blue box around this one, which is fine. This one was in there, but they didn't put a big box around it. But I'm good with either equation there. 9 is change in. I would even take delta for a day on that, because that is what that also means, but change in is the better answer. 10 is deceleration. Guess we'll pause the thing.
Yeah.
Okay, so some notes and some tips just about where this goes next. So not necessarily a quiz question, but this might be a test question because I wrote it up at the top of my paper, but I don't see it on tomorrow's quiz. Chapter 3 is about motion. And there's two unavoidable things that they did try to stress in the reading that are, I think, important to understand. One is that everything is moving. So right now, even though it may not look like it, this is moving. How is that moving?
Because the world's spinning.
Yeah, the world is spinning. What else is the Earth doing?
It's also
Going around the sun. The sun itself
It's stationary.
is not.
It's spinning.
Is moving through space. Like everything is moving on that grand scale. And if you went like super magnifying glass scale, like the molecules of that right now,
They're moving.
they're moving.
Oh,
They're,
yeah.
they're vibrating. The solid is moving less than what the liquid is doing. Now we can see the liquid's moving. But everything at some level is moving. And then the other thing they stress that's, I think, good to understand is there's a few simple equations that apply to all motion. Whether it's the Earth around the sun, whether that's a car down the street, or me walking to the next class, or whatever. Anything that's moving is going to obey the same equations. Those aren't quiz questions, but those are, I think, decent things to understand. In terms of reworking today's into next, you're going to read 3-4 and 3-5. 3-4 and 3-5 are going to have 4 new points. 2 of them are equation-y. There's one question that I'll just say, what is this equation? Because they're going to give you a new equation for something. The other one that's sort of like an equation is involved, but I'm not going to ask you for an equation, and I'll just leave that to your imagination to read and figure out what's going on. But there's a total of 4 points from the reading that reappear on the next quiz. The quiz grows to 15, so let's see our other changes. even though the book for now says they're going to use speed and velocity interchangeably, I'm just going to teach you the difference today to get it out of the way instead of waiting a couple chapters. But they're going to use the words interchangeably. So new question for next time, I'll ask you, what's the difference between speed and velocity? And I'm going to drop you some words from trig, and we'll see if any calculus people remember a trig word. Speed is a thing called a scalar, S-C-A-L-A-R. Velocity is a thing called a vector. Does anybody who's been through trig already know what the difference is between a scalar versus a vector?
Scalar, you're going up.
Disagree.
Oh.
Can you spell scalar?
S-C-A-L-A-R.
So velocity is vector.
Velocity is a vector, speed's a scalar. You can say that answer, but that doesn't actually help us if we don't know what those words mean.
Yeah,
I'll
that's
take
true.
them as a correct answer, but it would be even better if we understood what that even
Are they
meant.
lines?
It is not. Okay, vectors have a direction. Scalars don't care about direction. So if I'm talking about vectors, if this is 1, this would have to be
Two.
-1
-1 because I went
to the left.
the other way. So if I'm talking vector world, if this is 1, this is -1. Or maybe this is 1 west, and then this would be 1 east. There's somehow a direction involved in a vector. Velocities always have some sort of specified direction. Speeds don't. Speeds are scalars. Like if this is 1, this is 1. And this is,
1.
and that's,
1.
and that's.
1.
It doesn't matter. Every direction is 1. Okay, the direction doesn't matter for scalars, direction does matter for vectors. So in future chapters, they're not going to use those interchangeably forever. In future chapters, if they're doing velocities, they'll in some way show you a direction, like north, south, east, west, or positive versus negative, or something. But speeds are always positive, they have no direction, no one cares what direction they go. Let's see. Number 1 and 2 don't reappear. So those are gone for now, probably back for the test. 3 does reappear, but backward. It'll say, what is acceleration? And you'd say it's the rate of change of velocity. So what is acceleration? The rate of change of velocity makes it. 4 makes it, but backward. What is the average speed? That's figured out over a time period. 5 is back, but oppositely. I'll ask you, what is instantaneous speed? That's the speed at a given instant. So you're driving on the turnpike, the policeman has the radar gun on your car to decide whether to give you a ticket or not. Which of those 2 speeds is he concerned about?
Average.
Instantaneous. It is at that moment when you pass the trooper that gets you the ticket or not a ticket. If you go on a trip of 300 miles and you take 5 hours to do it, what's your average speed there? If you do 300 miles and you do it in 5 hours, 60 miles an hour. That's an average speed figured out over time. On your vacation drive, even if you average 60 miles an hour, were there some times you probably did 30? Were there some times you might have done 70? Maybe. Okay, but the radar gun on your car, that's measuring an instantaneous speed at that instant. Average is measured over time. Question about concepts there? Question that's not necessarily on this quiz. This seems brand new out of nowhere. I'll just ask you, just like I did, what is acceleration? And we said rate of change of velocity. I will ask you, what is velocity? So that's a new question. Jot that down somewhere. What is velocity? Answer is rate of change of displacement. Velocity is rate of change of displacement. Displacement is a synonym word in the book for now for distance, but I'm not going to use those words interchangeably because we're not going to long term, so I'm just going to use the right words from the get-go. I will ask you a sort of new question. It's new to this chapter, but it's not new to your life. Velocity is measured with what unit?
M over S.
M over S, meters per second is the way we'll prefer to read that. Acceleration is measured with the unit
M over S.
meters per second squared. Those were just on the test, so those aren't really new to our entire life, but they're new to be back in this chapter. 6 is still there. What's the equation for average speed? So we can do V equals S over T, and I don't care if you put the bar on the V or not, really, it doesn't matter to me. They told you in the reading, all of this stuff that they're going to do are going to be average speeds. They're not going to do any instantaneous speeds really this year. If you do physics with average speeds and traveling always in a straight line, that is algebra. If they start to do curved stuff or instantaneous speeds, that is calculus. And your life will be hard enough doing physics with algebra. You don't want to do physics with calculus. If you go to college and they say you have to take physics, ask them, is this physics with algebra or physics with calculus? If they say physics with calculus, ask them, do I have to take this course? Is this required for my major? And if it is not, do not take that course. That's not an easy course. Physics isn't easy. Calculus isn't easy. Put them together and do calculus-based physics. That is not something you want to sign up for unless it's required by your major to be an engineer. If you want to be an engineer or something, that's what you want to do. But unless you're majoring in engineering or some heavy-duty science, you do not want to take a calculus-based physics class just like for fun. Stick to the algebra world, and that's what our book will be, all about algebra-type physics. It's an oversimplified version. Like, does everything in the world travel in a straight line always at constant speed? No, that's oversimplified, but you'd rather have it oversimplified than be the real deal. So anyway, the equation is back for 6. 7 is gone, but it's worth a mention. Acceleration is positive anytime you speed up. Acceleration would therefore be negative anytime you slow down. That's a good thing to just understand for purposes of our life in this chapter. 8 is back. I would prefer this version. I'm not going to mark this version wrong, but I prefer this version. I'll also throw in a pitch for, there's going to be a lot of equations through the course of the year. You will not regret it if you get yourself a note card, and every time we have an equation like this, you jot it on the note card and build your list of equations. By the end of the year, that would be a handy tool, and it's a lot easier to build it one equation at a time than it is to build it like when we've had 50 equations and then you have to look them back up again. And it's a lot easier to organize like now because you're starting with an empty card. So you do with that what you will, but by the time we get to the final, it's a legal thing for you to have a note card with all the equations on it, and if you try to build that the night before the final, that's going to be a sleepless night. So you might want to build that day by day, just like you build your grade day by day. I get it. 9 stays the same. I'd like to go there with change in. 10 I ditched, but it's a worthwhile thing to just understand. If you have a negative acceleration, that can be called a deceleration. That's a synonym word. It's just same number but opposite sign. If your acceleration is 5, your deceleration would be negative 5. If your acceleration is negative 16, your deceleration is 16. It's the same number, different sign, acceleration versus deceleration. I think that describes the quiz. So difference between speed and velocity, I said average speed definition, instantaneous speed definition, velocity definition, acceleration definition, 2 units for the velocity and acceleration. Now here's a new one. What does uniform acceleration mean? Uniform is a synonym for constant, yeah. So I'll ask what's uniform acceleration, you could say constant acceleration. 2 equations are on there, change in is on there, that's what's on Question about understanding words. So here's a couple problems. When you go to do the problems, you can read these sort of like you listen to the Charlie Brown's teacher. You ever watch the Charlie Brown movies where it sounds like Most of the stuff in the paragraph does not matter. But what you want to skim for is numbers and pay attention to the units, because the units give themselves away. So a question like this would come out of a paragraph that's like 500 kilometers, 10 hours, find the velocity. But they'll have filler information that doesn't matter. What you're going to need to recognize is something hopefully the test already helped you do is when you see a unit, that gives away what kind of thing you're measuring. If you haven't absorbed that yet, I gave you a thing I called the cheat sheet the day I gave it to you. Keep that handy somewhere. Keep the cheat sheet in your area. Kilometers is a measurement for who? Distance. Distance is variable all year long, will always be. It is not. Distance is variable. Somebody find the cheat sheet. We don't know. It is an S. Distance will always be an S. I don't know why. I wish it was a D. Make life easier if it were, but it's not. Sorry, it's not how they wrote the book. So kilometers is a distance. Distance is variable is an S. Hours is a measurement of time. Time's variable
T.
is a T. I asked you to find the velocity. The variable for that is V. If it helps you when you read the question to make yourself that little itemized list of what's what, feel free. I won't necessarily require that of you, but people that aren't super math strong, that's a good idea. They tell you 500 kilometers, identify that as an S. They talk about 10 hours, identify that as a T. They ask a velocity, identify that as a V. And then set out through your note card, if you have one, is there an equation in our life that has S, T, and V in it?
Yep.
Yes. This. And then just stick the numbers in it. I don't know the V, so I'll leave that as a V. I do know the S, I'll jam in there. 500. I do know the T, I'll jam in there. The 10. The variable's already alone, hooray for that. I don't have to do any opposites or solve. Sometimes you do, sometimes you don't. Just do 50 divided, or 500 divided by 10, and it'll show up to 50. Question about that? Then here's the bad news for you. In math class, that's all I ever would expect of you is a 50. And in here, I'm going to always expect two more things to happen on every answer.
What's per second? Meters per second.
Some kind of a unit. Okay, for this, we just did kilometers divided by hours. So I need a unit here of kilometers per hour. What's another thing we did last chapter on the test? Significant digits. We're going to adopt a new rule for significant digits to simplify our life. It's the same rule we adopted in chem. It's the same rule they adopted for me at Penn State a million years ago when I was in college. They went with the strategy of just always have 3. Just always do 3. Forget the rules. The rules exist. Some other science class somewhere, they may insist on you obeying all those significant digit rules about rounding before, rounding after, fewest places, all that stuff. Those are real rules, but I'm not going to impose them all year. I'm just going to say always put 3. At present, how many significant digits does this have? 1. I'd like to make it have 3. How can I make that have 3? 50.0. 50.0 just made that be a 3 significant digit answer. We're just going to deal with that. We may run out of time today, but I gave you a sheet that I said we would do sometime. We may start that today, we may not. But we'll practice our significant digit writing off of that sheet. So keep that handy day by day till we can punch that out. Question about that? A follow-up question? Maybe that's like a part A in the homework. Part B, I might ask you to change that to meters per second. And there's a trick that I taught you on cheat sheet day that we've used at least 2 other days. This is at least the 3rd time we use this trick, because I originally said we would use it probably dozens of times or 100 times. I don't remember what I estimated it as. But we're going to use it a decent bit. There's a cheat that we can change kilometers per hour to meters per second. Anybody remember the quick cheat to change kilometers per hour to meters per second? Multiply by 5/18. So if your calculator's handy and it's showing you a 50 already, just go times 5, divide 18, punch it a punch it a punch. It's 13 point something, I don't know. Is it a lot of 8s?
Yeah.
Okay, so if it's 13 point and a screen full of 8s, I want how many digits? 3, always 3. So keep the 1, keep the 3, keep the decimal, and then if you have a bunch of 8s, we round to 9. Question about that? So here's another like blah 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 story. So like blah blah blah, 10 meters per second, blah blah blah, 100 meters per second, blah blah blah, 18 seconds. They could tell you any kind of story they wanted to about trucks or cars or trains or whatever they're doing with it. What is meters per second code for? Velocity. The variable for that is a v. Meters per second again, that's some kind of v. You can't have a story where everything's v. So sometimes what they'll do is they'll tell you the original speed of the car was 10. So that's what this little subscript is for. When you see a VO, the O stands for like the original velocity, the starter velocity. This is somewhere later in the story. They'll probably do F's for those, F standing for final. So there's an original speed, there's a final speed. That's what these little subscripts are for. They're both in the V family, but you need to differentiate between who's who. Seconds is a measurement of time, variable t. And then at the last question, I could say, like, what's the acceleration? Acceleration's variable is a. So if making the little list of facts helps you as you read the story, do it. And then we'd scan our memory banks. Do we have any equations with V's in them, and T's in them, and A's in them? And so far, we only have 2 equations to choose from, so there's not like a radical choice here. You know, that's our play to make. Just stick the numbers in. We don't know the acceleration. We do know final speed, 100. We do know original speed, 10. We do know time, 18. I would probably not use that one personally. If you like that, that's fine. I'd probably use this one. The delta represents change in. I would just look to these and real quick compute what is the change. 90 over 18. If you do the math on this, it's going to head you anyway to 90 over 18. It doesn't matter which way you're thinking. Those are both true. I just prefer to think that way. We math that up. The screen will say 5. And then I would criticize that twice. 5.00 is better because now that's a 3-digit answer. Meters per second squared is going to always be the acceleration unit. Because we already had a meters per second, we divided by another second. So those seconds just like teamed up. That's why the seconds got squared there. You don't have to think that through every time. You can just kind of memorize that's what that is. It's meters per second squared acceleration all the time. That is the acceleration. What if I asked you for the deceleration to just be tricky? Change the sign. What if I told you the car was originally 100 and then the final was 10, so they hit the brakes? If I switched the 110 and had them hitting the brakes instead of the gas, what would the acceleration have been? -5. And therefore that deceleration, positive 5. So it's the same number no matter what, it's just a question. Be careful your signs depending on what they ask. Question about the concept? So homework we're doing from this, there is a 1 to 15, trying to work the two equations, one equation or the other. Let's do worksheet a little bit real quick, just to pound out maybe the top part, and then we'll call it a day. Somebody top line, just do a quick significant digit count of how many there are. Rattle me off a quintet of answers from that top row. Anybody?
3, 4, 3, 2, 5.
I agree with all of that. So top row is going 3, 4, 3, 2, 5. Anybody not understand anything out of the 3, 4, 3, 2, 5 line of counting how many there are? Somebody other than Alyssa, go bottom row of 5.
4, 3, 3, 3, 8.
Agree. Bottom row goes 4, 3, 3, 3, 8. Anybody want explanation of bottom row, why the counts there went 4, 3, 3, 3, 8? Okay. Then let's make there be 3. Sometimes they're too long and we're going to have to, by
Rounding.
rounding, sometimes they're too short and we're going to have to make a longer answer by tacking on some zeros. But we're looking to keep the rough size of the number the same, but we're looking to just have it be a 3-digit answer instead of a whatever it is at present. If you've been through Chem already, Chem had a weird rule about rounding and fives and evens and odds. Physics does not acknowledge that rule. So I'm not even going to mention that rule or get back into that rule. But if you're remembering a rule about fives and evens and odds and things, that's not a thing for us this year now. First one, can somebody, it's too big, can somebody round it so it's a 3-digit thing?
265.
264 is correct. Because we don't have enough to round it up to 265, because the 4 that followed the decimal was too little. So 264 would be the preferred answer on a paper you're giving me if your calculator screen read what that paper is typed to you. Let's work right. So your screen on your calculator reads 32 point all that stuff. If we round it to make it have 3 digits, 32.3. Because after the decimal is where the 3rd digit is. That's where we want to round, and there's not enough to round it up. The 3rd one through that line, round it so it has a 3rd place. 7.27 is true. On the 4th one, what important knowledge do you need to have about the zeros on this 4th one? They don't count. The zeros are only holding a place. Those zeros don't count toward your count of 3 yet. The 5 matters, the 7 matters, and then it's going to be rounding time. So what's that going to look like?
0.00573.
It is 0.00573. 5, we already encountered 5 on the board once today. 5 wasn't enough digits. So to make 5 be a 3-digit number without changing its worth, you have to put 5.00. 5.00 is now a 3-digit answer, but it's still the same number at its heart. It's still 5. Anybody top row not getting what we're doing? Okay, bottom row, 73.0. 23.5, because the 5 is enough to round the 4 up to be a 5. In chemistry, that wouldn't have happened. Okay, but that we're doing traditional rounding. Middle one? 23.5. 355, which broke the chemistry rule again, but we don't care. 8,580 is what we'd get if we rounded in the 3rd position's worth of numbers. Anybody on that row, Matt? How do we make 700,000 have a 3rd digit?
Bar over the
bar over the second zero. So we put a bar over the second zero, now that's a 3 significant digit answer. 58.0. Go again. 567,000. 0.0054 is deceptive because the zeros at the beginning don't count. So how many digits does that have at present? Only 2. To make a third digit, tack a 0 after the 4, and that would make there be a third significant digit. Again, the 000 part does not count on the 0002263.
Take off the 3.
Take off the 3. 0.000226. 7, it's just like 5 from earlier. 7.00. 4.6.
I don't know.
I don't know. The 0.0, realize that first 0 does not count. Let's finish this row and then we'll run away. So 0.0, 502. The 009, add 2 zeros. The 610,000, bar on the first 0. Keep that paper. We'll do some conversions with metric another day, but today's not the day.